Welcome to our comprehensive guide on sampling methods in quantitative and qualitative research. Sampling is the process of selecting a subset of units from a larger population to draw conclusions about the entire group. Proper sampling is crucial for ensuring the validity and accuracy of research results. It helps researchers balance representativeness with practical feasibility. In this course, we'll cover two main categories of sampling methods: quantitative and qualitative approaches. Quantitative methods include simple random, stratified, cluster, and systematic sampling. Qualitative methods include purposive, snowball, maximum variation, and theoretical sampling. Each sampling method has a unique approach and is suitable for different research contexts. Throughout this course, you'll learn detailed explanations of each method, their advantages and limitations, and how to determine appropriate sample sizes. We'll also explore visual comparisons between different sampling approaches, like this example showing stratified sampling versus simple random sampling. Get ready to dive into the fascinating world of research sampling methods. What is sampling? Sampling is the process of selecting a subset of units from a larger population to draw conclusions about the entire group. When researchers study a population, they often can't examine every individual member. Instead, they select a representative sample. The purpose of sampling is to enable researchers to study manageable portions of populations, save time and resources, while still making valid inferences about the whole. A good sample must be representative of the population, reflecting its key characteristics. Sampling is widely used in various fields, from market research and political polling to quality control in manufacturing and scientific studies. Understanding what sampling is provides the foundation for exploring different sampling methods and their applications. Why is sampling important in research? Proper sampling ensures the validity of research. It provides the foundation for making accurate conclusions about a larger population based on a smaller subset. Well-designed sampling enhances research accuracy. When done correctly, it minimizes errors and biases that could otherwise distort findings and lead to incorrect conclusions. Rigorous sampling builds trustworthiness in research. When researchers clearly describe their sampling methods, it creates confidence in the findings among both scientific peers and the broader public. Sampling strikes a crucial balance between representativeness and feasibility. It allows researchers to study a manageable subset while still obtaining results that accurately reflect the larger population. In conclusion, sampling is the foundation of reliable research. Whether using probability or non-probability approaches, proper sampling methods make research projects both scientifically sound and practically feasible. In research, sampling approaches fall into two major categories: quantitative and qualitative. These approaches differ significantly in their goals, techniques, and outcomes. Quantitative research prioritizes statistical representativeness through probability-based sampling techniques. These methods ensure that every member of a population has a known chance of being selected. Probability sampling methods include simple random sampling, stratified sampling, cluster sampling, and systematic sampling. These techniques help researchers obtain samples that statistically represent the larger population. In contrast, qualitative research emphasizes in-depth understanding of phenomena through non-probability sampling techniques. These methods select participants who can provide rich, detailed insights into the research question. Non-probability sampling methods include purposive sampling, snowball sampling, quota sampling, and convenience sampling. These techniques help researchers gain deeper insights rather than statistical representation. Qualitative research often employs different types of interviews to collect rich data. These include structured interviews with fixed questions, semi-structured interviews that allow flexibility, and unstructured interviews that follow natural conversation flow. Let's compare the key differences between quantitative and qualitative sampling approaches. Quantitative sampling typically involves large sample sizes and random selection to achieve statistical generalization. In contrast, qualitative sampling uses small, purposefully selected samples to gain rich, detailed insights about phenomena. Simple random sampling is a fundamental quantitative sampling method where every member of the population has an equal and independent chance of being selected. A helpful analogy is to imagine a lottery machine with numbered balls. Just as in a lottery draw, each numbered ball, representing a member of your population, has an equal probability of being selected. In practice, simple random sampling can be implemented using random number tables or computer-generated random numbers. Each member of the population is assigned a unique identifier, and numbers are randomly selected to determine the sample. Simple random sampling is one of several quantitative sampling methods. It differs from other approaches like stratified or systematic sampling, which we'll explore in subsequent sections. While this image shows systematic sampling, selecting every third member, simple random sampling would instead select members randomly without any pattern. Each member would have an equal probability of selection, regardless of their position. Let's examine the advantages and disadvantages of simple random sampling. The key advantages include unbiased selection, strong external validity, ease of statistical analysis, and the ability to generalize findings to the whole population. However, there are disadvantages to consider. Simple random sampling can be expensive, time-consuming, requires a complete list of the population, and still has potential for sampling error, especially with smaller sample sizes. Here's a practical example. Imagine a researcher wants to survey 50 students from a university with 5,000 students. First, they would obtain a complete list of all 5,000 students. Next, each student would be assigned a unique number from 1 to 5,000. Then, a random number generator would be used to select 50 numbers within that range. Finally, the students corresponding to those selected numbers would comprise the sample. To summarize, simple random sampling ensures every population member has an equal probability of selection. This creates representative samples with strong external validity, but requires complete population lists and can be resource-intensive. Quota sampling is a non-probability sampling method that ensures representation of specific subgroups within a population. Quota sampling has several key characteristics. It's based on known population proportions and ensures representation of important demographic groups. Unlike stratified sampling, it doesn't use randomization within subgroups. This method is commonly used in market research and opinion polls. Here's an example of age-based quota sampling. The researcher has set quotas to ensure proper representation across different age groups. The table shows specific numbers needed for each age bracket, totaling 60 participants. This illustration shows quota sampling in action. Researchers filter a diverse population to find participants matching specific criteria, in this case, males over 50 years old. Once the quota for this demographic is filled, no more participants from this group are included. It's important to understand the difference between quota sampling and stratified sampling. While both methods divide the population into subgroups, stratified sampling uses random selection within each group. Quota sampling, on the other hand, simply takes the first available subjects that meet the criteria, making it a form of convenient sampling. Let's examine the advantages and limitations of quota sampling. On the positive side, it ensures representation of key subgroups, is cost-effective, and useful when a sampling frame is unavailable. However, it has significant limitations, including vulnerability to selection bias, limited generalizability, and the influence of researcher judgment on participant selection. Here's a practical example of quota sampling in action. A market research firm needs to interview 100 smartphone users. They set quotas based on age groups: 30% for ages 18 to 24, 40% for ages 25 to 34, and 30% for ages 35 and above. Researchers then select participants until each quota is filled. The key takeaway is that quota sampling ensures demographic representation, but lacks the statistical robustness of probability sampling methods like stratified random sampling. In quantitative research, calculating the appropriate sample size is essential for achieving statistical confidence. The most commonly used formula for calculating sample size is shown here. Let's break down what each variable represents in this formula. Let's work through a practical example of how to calculate sample size. For a 95% confidence level with maximum variability and a 5% margin of error, we calculate a sample size of approximately 385 participants. This visualization shows how confidence intervals from different samples can either include or exclude the true population mean. Larger sample sizes produce narrower confidence intervals, increasing the likelihood of capturing the true population parameter. Let's review some key points about sample size formulas. Snowball sampling is a qualitative research technique where existing participants recruit future participants from among their acquaintances. In snowball sampling, researchers start with a small group of initial participants who match their criteria. These initial participants then refer other potential subjects with similar characteristics, creating a chain of referrals. This method is particularly useful for reaching populations that are difficult to access through conventional sampling methods. The name snowball sampling comes from the idea that, like a rolling snowball collecting more snow, your sample grows larger as participants refer others. Snowball sampling offers several advantages in qualitative research. However, it also comes with important limitations that researchers must consider. Snowball sampling is one of several chain referral methods used in qualitative research. Other related approaches include key informant sampling, targeted sampling, and respondent-driven sampling. Maximum variation sampling is a purposeful qualitative sampling strategy that deliberately selects participants with diverse characteristics. This approach aims to maximize diversity among participants relevant to the research question. The goal is to capture a wide range of perspectives and identify patterns that cut across varied cases. Researchers using maximum variation sampling select participants who differ across key characteristics such as demographics, socioeconomic backgrounds, geographic locations, experiences with the phenomenon being studied, and professional backgrounds. The process of maximum variation sampling involves identifying key dimensions of variation important to your study, then selecting cases that represent the extremes and middle of these dimensions. This approach ensures representation across all important variations and allows researchers to analyze both unique cases and common patterns. Here's a practical example of maximum variation sampling in action. A study of a statewide maternal nutrition program deliberately sampled project sites in rural, urban, and suburban areas. The researchers also included women from various categories who were accessing maternal services. This approach ensured that findings would reflect the diversity of program participants. Maximum variation sampling is particularly useful when your population is highly diverse, when you need to explore how a phenomenon manifests across different contexts, when seeking to identify common patterns that cut across variations, and when you want to increase the transferability of your findings to other settings. Unlike other sampling methods that might focus on homogeneity or convenience, maximum variation deliberately seeks out diversity to strengthen research findings. Exploring the key outcomes of qualitative sampling. Unlike quantitative approaches, qualitative sampling aims to provide deeper understanding rather than statistical generalization. The first key outcome is rich insights. Qualitative sampling provides detailed descriptions that capture context, emotions, and subjective experiences of participants. The second key outcome is data saturation. This is reached when new data no longer provides new insights or themes, indicating comprehensive understanding. Qualitative sampling achieves depth of understanding by exploring underlying motivations, beliefs, and contextual factors that influence behavior. Finally, qualitative sampling captures nuanced perspectives, revealing diverse viewpoints and complex social phenomena that might be missed by more rigid approaches. To summarize, qualitative sampling produces rich, detailed narratives, achieves saturation of themes, provides deep contextual understanding, and captures complex, nuanced perspectives that quantitative methods might miss. While qualitative sampling provides rich insights, it's important to understand its key limitations. This summary highlights 5 critical limitations of qualitative sampling methods. The first major drawback is limited generalizability. Findings from small, specific samples cannot be easily applied to broader populations. The second major limitation is researcher bias. The researcher's background, beliefs, and values can influence data collection and interpretation. Third, qualitative findings are highly context dependent. Results are specific to the particular setting and participants of the study. The nature of qualitative data itself contributes to these limitations. Unlike quantitative data, which is numerical and more easily standardized, qualitative data is diverse and descriptive. Qualitative research faces additional practical challenges. These include intensive time and resource requirements, difficulties in replication, subjectivity in analysis, reliability concerns, and ambiguity in determining adequate sample sizes. Despite these limitations, qualitative data offers rich visualization opportunities. However, the complexity of these visualizations can sometimes obscure important patterns or introduce additional biases. To address these limitations, researchers can implement several strategies. These include triangulation with multiple data sources, practicing reflexivity about their own perspective, providing thick descriptions of context, verifying interpretations with participants through member checking, and maintaining a detailed audit trail of research decisions. Rather than diminishing the value of qualitative research, acknowledging these limitations strengthens the credibility of findings. Qualitative sampling provides unique insights that cannot be captured through quantitative methods alone. Sample size justification in qualitative research follows a fundamentally different approach from quantitative methods. Unlike quantitative research with its statistical formulas, qualitative studies focus on the depth and richness of data rather than statistical power. A key principle in qualitative research is data saturation, the point at which collecting more data no longer generates new insights. In qualitative research, sampling focuses on selecting participants who can provide rich, in-depth insights relevant to the research question. Researchers typically continue collecting data until they reach saturation, when additional interviews or observations yield diminishing returns in terms of new information. Several factors influence the appropriate sample size in qualitative research. This stands in stark contrast to quantitative research, which typically relies on statistical calculations to determine sample size. When justifying sample size in qualitative research, several key insights should be considered. Remember, the goal of qualitative sampling is not to achieve statistical representativeness, but to capture depth and meaning through carefully justified sampling decisions. Recent advances in artificial intelligence and machine learning are revolutionizing sampling methodologies in research. AI algorithms now analyze vast datasets to identify patterns, enabling researchers to develop more efficient and accurate sampling strategies. These technologies can predict trends within data and automate the selection process, reducing human bias while increasing efficiency. One major advancement is the ability to dynamically adjust sampling frames in real time, allowing researchers to mirror real-world population changes. Machine learning models continuously refine the sampling process, automatically including new data points as they emerge. This image illustrates how AI systems can sort and categorize big data, transforming raw information into structured samples for analysis. These AI-powered sampling methods offer significant benefits for researchers. They provide higher accuracy in population representation while reducing costs through automation. Research experts have formed important perspectives on sampling methodologies based on years of experience and evolving research practices. Experts increasingly advocate for mixed methods research, combining qualitative and quantitative approaches in the same study. This integration enables researchers to gain more comprehensive insights and strengthen the overall validity of their findings. For example, researchers might use quantitative techniques like convolutional neural networks to process large data sets, then apply qualitative analysis to interpret patterns and outliers. Experts emphasize the importance of flexibility in sampling strategies. Research is rarely linear, and methods often need to be adapted in real time to capture emerging trends or unexpected directions. Modern researchers employ a variety of data collection and analysis methods. This diversity allows them to adapt their approach based on preliminary findings or changing research contexts. Experts provide clear recommendations for effective sampling. They advise researchers to combine multiple sampling strategies, adjust sample sizes based on emerging data, document all sampling decisions thoroughly, and be transparent about the limitations of their approach. As one leading research methodologist states, the most robust sampling approaches recognize that research is dynamic and requires ongoing methodological reflection and adaptation. These expert insights highlight that effective sampling is not just about selecting the right method, but about remaining adaptable and integrating diverse approaches throughout the research process.